Hi, grade 7 students. This is day 2, lesson 8-2A. Please pause this video in a few seconds and read carefully page 378. Then come back to this video and we'll try and help you a little bit as to how to handle some of these problems. Thank you. Okay, you should have read page 378. Let's take a look at the first problem, problem number 4, that says, Destiny wants to buy a cookie from a vending machine. The cookie costs 45 cents. Destiny uses exact change. How many different combinations of nickels, dimes, and quarters can she use? Well, the first thing to think about is that we want to make sure we're being organized in how we do this. There's a couple of ways this could be done, but I'm going to show you one way. I'm going to get you started on it, and then I'll let you finish the rest of the problem on your own. So, the first thing I'm going to do is I'm going to create columns for nickels, dimes, and quarters. Nickels, dimes, and quarters. And I'm going to start thinking to myself, how can I make 45 cents out of nickels, dimes, or quarters? Well, since quarters is the largest value and it's worth 25 cents, I'm going to start by thinking to myself, is there a way to do it with, say, 2 quarters? And that would be no, because 2 times 25 is 50 cents, and that's already too much. And the problem says that you have to have exact change. So I'm going to think about, what if I have 1 quarter? Is there a way to make 45 cents out of 1 quarter with nickels and dimes? And in my mind, I'm thinking, yes, there is. What if I have 2 dimes and 0 nickels? The 2 dimes would be 20 cents. The 1 quarter would be 25 cents, and together that makes 45 cents. So that's one way. So far, we've found one way. Is there another way to do it with 1 quarter? What about 1 quarter and 1 dime? That would be 25 cents, and 10 cents makes 35 cents. How do I get to 45 cents from 35 cents? Well, that would be 2 more nickels. So there's a second way, right? Is there another way to do it with 1 quarter? Notice this number's dropping and this number's getting bigger. We're trying to be organized here. What if I do it with 0 dimes? And how many nickels would I need? Well, to get from 25 cents, 1 quarter, to 45 cents, I'd need an additional 20 cents. And 20 cents is how many nickels? 20, let's see, how many groups of 5 cents makes 20 cents? 4. Now I've got 3 different ways. Is there another way to do it with 1 quarter using nickels and dimes in some sort of fashion? The answer to that is no, I can't think of another way. So guess what? From this point on, we're only going to be doing this with 0 quarters. We can't go higher than 1 quarter because 2 quarters is 50 cents. So, is there a way to do it with a lot of dimes? Well, 5 dimes is too much and 4 dimes is not enough. 4 dimes is 40 cents. To get to 45, I'd need 1 nickel. Is there another way to do it with 0 quarters? Well, we've already tried 4 dimes and that worked. What if we use 3 dimes? 3 dimes would be 30 cents. To get from 30 to 45, I'd need another 15 cents. 15 cents out of nickels. That would be 3 nickels. There's my next way. I'm going to let you finish problem 4 on your own. I will tell you that the answer to problem 4 is bigger than 5 ways, obviously, but smaller than 10 ways. So look carefully, continue this pattern the way we've described it, and try to find the answer. It's somewhere between 5 ways and 10 ways. Let's move on to problem 5. Rosa checked out 3 books from the library. While she was at the library, she visited the fiction section, the nonfiction section, and the biography section. What are the possible combination of book types that she could have checked out? Keep in mind, she checked out 3 books. 3 books. Fiction, nonfiction, biography. Those are our choices, right? How many different ways could she have done that? Well, here's way number one. What if they were all the same? What if they were all fiction books? That's a possibility, right? 3 books. She went to the fiction, nonfiction, and biography sections and got all fiction books. What if she decided, you know what? I'm going to get a fiction book, a nonfiction book, I'm sorry, a fiction book, and a nonfiction book. What if she went and got a fiction book, a nonfiction book, and a nonfiction book? So far, that's 3 different ways, isn't it? We still haven't even brought in biographies yet, have we? I'm not really sure I like what's happening here because I'm not sure this is really creating an organized list. It's going to be kind of a haphazard list if I'm not careful. So I'm going to start over here. What if I started off again with fiction, 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 and then I thought to myself, well, there's 2 other types of books, right? There's fiction, nonfiction, and biography. What if I started thinking about those fancy-dancy, shall we say, oh goodness, the name escapes me. Sorry. Anyway, let's just proceed. I'm sorry. Fiction, fiction, nonfiction, fiction, fiction, biography. What if I said fiction, nonfiction, biography? Is there any other way we could do this with at least one fiction? Wait a minute, what if I had fiction, nonfiction, and nonfiction? That'd be a 5th way, wouldn't it? What about fiction, biography? That'd be another way. Is there any other way to do it with one fiction book? 2 fictions, fiction, nonfiction, fiction, biography, nonfiction, biography, nonfiction, nonfiction, biography, biography. Okay, so that's our 6th way. Now let's start thinking about our 7th way. If there is another way, what if we put nonfiction here? We've already, we think, come up with all the different ways that have a fiction book in it. So what if it's only nonfiction and biographies? Well, I could go, how about nonfiction, nonfiction, nonfiction? That'd be one way. What about nonfiction, fiction, nonfiction? And what about nonfiction, fiction, fiction? Are there any other ways to do this that don't, oh, wait a minute, we did a boo-boo here. We can't have fiction in here anymore. It's got to be biography, isn't it? Yeah. Because we're not going to use fiction books anymore because we've already exhausted all the use of the fiction book ways. So now we've shown all the different ways we can do this with the nonfiction books. What's left? Well, all the different ways that show only a biography being taken out by this young lady named Rosa. So, I'll give you a hint. The answer you're seeking is something bigger than 9 ways and something smaller than 12 ways. That's the answer to number 5. But this is one way of doing it, trying to create an organized list. I'll let you work out the rest of this. Okay, number 6. Steve and Derek are playing a game. Steve says he's thinking of 2 integers that are between -10 and 10 that have a product of -12. If Derek has one guess, what's the probability that he will guess the correct pair of numbers? Okay? in my mind, the first thing I'm thinking about is writing down those numbers that they say are part of their thought process. So I'm writing them all down up here on the board. Oh boy. So here's our set of numbers that these gentlemen are thinking about. Whoops, we went off the board a little bit. Let's turn this. Now, let's reread the problem. Steve and Derek are playing a guessing game. Steve says he's thinking of two integers between -10 and 10. In other words, we don't want to think about -10 and 10. We only think about the numbers that are between those two. And these numbers have a product of -12. In other words, the two numbers, when you multiply them together, make -12, because a product is the answer to a multiplication problem. And then it says, if Derek has one guess, what's the probability that he will guess the pairs of numbers? Well, how many different ways can you come up with two numbers from this list that multiply together to make -12? Well, here's a pair, -6 and +2. That's a pair of numbers that multiply together to make -12. Can you see another pair? I can. How about 6 and -2? How about -3 and +4? And finally, how about +3 and -4? Okay, so it's from this list of 4 pairs, and the problem says, what's the probability that he will guess the pair of numbers? In other words, Derek's going to guess one of these 4 pairs. Steve has in mind one of these 4 pairs. What's the probability that Derek will guess correctly? You're looking for a fractional answer here. Remember, probability is favorable outcomes over all of the outcomes that exist in a situation. Hint, how many outcomes exist? There are 4 pairs. Looking for a fractional answer. Okay, we're moving on to number 3. No, we're not moving on to number 3. Excuse me. We're moving on to number 7, rather. Before we do number 7, I want to talk about some numbers. If I say to you the number 3 and the number 11, and I say to you, how do they compare? You could say, well, 11's bigger than 3. You could say that 3 is smaller than 11, but that's not being very specific, is it? So here's a way in which you could compare these two numbers. Somebody could say 11 is about, not exactly, about 3 times greater than 3. Okay? It's not an exact answer, because you know that 3 times 3 is 9, and that's not exactly true. Or you could say 11 is about 4 times greater than 3, because 3 times 4 is 12, and 12 is really close to 11. Somebody could also say that 11 is 8 more than 3. Or somebody could say 3 is 8 smaller than 11. That's the kind of thing they're looking for in problem number 7 when it says, how do those numbers of charcoal grills and gas grills compare to each other? They want some sort of sentence in which you're describing the relationship. If you'll notice, charcoal grills are 7.9, be careful, look at the labeling, 7.9 million grills. And gas grills are 4.3 million grills. How do those numbers compare? Come up with some sort of sentence to describe them. On to the next problem. Use the following information. In the World Series, 2 teams play each other until one team wins 4 games. And then we've got 3 different problems to talk about. The first problem, problem 8, says what is the smallest number of games needed to determine a winner of the World Series? Let's imagine that the Tigers, Detroit Tigers, were playing in the World Series against, how about the Milwaukee Brewers? It's not going to happen this year. Well, maybe it will. Who knows? But imagine they're playing in the World Series. In order to win, somebody has to have 4 total wins in all. One of the two teams needs to win 4 total games. So what's the smallest amount of games you could play? What if the Tigers won the first game, the Brewers won the second, the Tigers won the third, the Tigers won the fourth, and the Tigers won the 5th game? Well, then the Tigers would win the World Series, wouldn't they? Is 5 games the smallest amount of games you could play? Or could you play an even smaller amount? That's what problem 8 is talking about. Let's look at problem 9. What is the greatest number of games needed to win the World Series? What is the greatest number of games? Well, let me give you an example. What if the Tigers won the first one, the Brewers won the second, the Tigers won the third, the Brewers won the fourth, the Tigers won the 5th game, and the Brewers won the 6th game? Has anybody won the World Series yet in this particular case? No, because nobody's won 4 games yet. In this particular circumstance, the Tigers have won 3 and the Brewers have won 3. How many total games would you have to play in this circumstance in order to win the World Series? That's what problem 9 is about. Now look at number 10. Number 10 says, how many different ways can a team win the World Series in 6 games or less? Hint, the team that wins the series must always win that last game. I'll give you a hint on problem number 10. The answer is somewhere between 14 and 17. In other words, the answer could be 14 games, 15 games, 16 games, or 17 games. I'm not going to tell you which one, but I'm going to give you a way to start this off. Let's imagine, of course, we're talking about the Tigers and the Brewers still. Now remember, the problem says for problem 10, you're winning it in 6 games or less. So one way the Tigers could win it is to win the first 4 games. Another way they could do it is to win the first 3 games, lose the 4th game, and then win the 5th game. Another way they could do it is win the first 2 games, lose the 3rd game, and then win the next 2 games. Another way they could do it is by winning the first, losing the second, and then winning the next 3 games. Already I've come up with 4 different ways. What if the Brewers win the first and then the Tigers win the next 4? That would do it. Now I've come up with 5 different ways. Remember, the answer is somewhere from 14 to 17. Could be 14 games, 15 games, 16 games, or 17 games. You see if you can figure it out. On to number 11. What is the probability that a person between the ages of 35 and 49 talks in his sleep? Write the probability as a fraction and as a decimal. Well, if you look at that picture there, for 39 to 49-year-olds, it talks about 15%. I'm not going to do that one, but I'm going to show you what you need to do for a different age level. I'm looking at age level 18 through 24. Age level 18 to 24, it says 19%. What do they want you to, oh, no, I'm sorry, it does not say 19, it says 29%. What do they want you to do? They want you to change that into a fraction, and they want you to change that into a decimal number. Boom, done. Percent means hundreds. If this could be simplified, I'd simplify it, but in this case I don't have to. And then how do you change a fraction into a decimal? Well, in this case it's easy. Since it's hundredths, we fill the hundredth spot, 29 hundredths. 29 hundredths is the same thing as 29 hundredths. So we're done. That's what they want you to do there. Number 12. At 2 p.m., Cody began writing the final draft of his report. At 3:30 p.m., he had written 5 pages. If he needs to write and finish 8 pages, how long will it take him to do that? When will he finish if he needs to do 8 pages? Well, the first thing I noticed is that Cody did 5 pages in 1 hour and 30 minutes. Did you notice that? He went from 2 o'clock to 3:30. That's an hour and 30 minutes. The thing that jumps into my mind here is I'm not going to like the fact that there's 2 labels here, hours and minutes. So I'm going to change this into just plain minutes. And an hour and 30 minutes is really 60 minutes plus 30 minutes, or 90 minutes. So he's able to do 5 pages in 90 minutes. Guess what? Proportion time. Okay? If he can do 5 pages in 90 minutes, we need to solve for 8 pages. How many minutes it's going to take him to do 8 pages? Now, after you solve that, you still need to take those amount of minutes and figure out what time of day he's finishing. What do I mean by that? Well, I'm not going to give you the exact answer here. I'm going to show you how to do it with a different answer. That's not the one you need to seek, okay? So don't get confused by that part of it. But let's say you solve this proportion and you decide that x equals 150, okay? That x equals 150. How would you use that to find the time of day? Well, here's how. We know that he started working at 2 p.m. 150 minutes, if you subtract 1 hour's worth of minutes and then subtract another hour's worth of minutes, that tells me that 150 minutes is 2 hours and 30 minutes. See it there? 2 hours and 30 minutes. Now, if I take those 2 hours and 30 minutes and I add them to the time we're already at here, that would take me to 4:30 p.m. That's the kind of work you need to do here. I'll give you a clue about the answer. The answer is somewhere between 4 p.m. and 4:30 p.m. Somewhere between 4 and 4:30. Next one. Rebecca's shopping for fishing equipment. She has $135 in her pocket and has already selected items that total $98.50. If the sales tax is 8%, will she have enough to purchase a fishing net that costs $23? Well, she has this amount of money. She wants to spend this amount and, whoops, wrong, $98.50. And she also wants to spend this amount as well. In other words, she wants to spend a total of $121. Well, right off the bat, it seems like she does have enough, doesn't she? But it says you also have to add sales tax to this. The question is, once you add the sales tax, will she have enough net? Do you remember how to figure out sales tax and what to do with that? Well, let me give you a different number. Instead of this number, what if you had to figure out the sales tax on $90 and the sales tax is 8%? How would you do that? Well, change this into a decimal number and multiply by the $90. In this particular case, it would end up being $7.20. Then you'd have to add that $7.20, and the total value is $97.20. Something is beeping. Not sure what.